second order density of the process, that is I need to find f x1 x2 of x1 comma x2. Let me consider x of t1 equal to x1 and x of t2 equal to x2. So here I have my x1 equal to p plus q into t1 and my x2 will be equal to p plus q into, the time is here t2, so p plus q into t2. Solving, we have x1 is p plus q t1, x2 equal to p plus q t2. Subtract one from the other, I will have x1 minus x2 equal to q into t1 minus t2. Therefore, I get the value of q. My q will be equal to now x1 minus x2 divided by t1 minus t2. Now having got q, I can easily find my p. I know that p is nothing but x1 minus q times t1. So this is going to be x1, I will have x1 plus, I will have minus x1 t1 minus x1 t1 plus, I will have x2 t1 divided by my t1 minus t2. Try to simplify this. When I simplify this, I will have an x1 t1, I will have a negative x1 t1, which will get cancelled. So I will only have a t2 x1 minus t1 x2 divided by t2 minus t1. This will be my p value. Already we have our q value. Our q value that we obtained was x1 minus x2 divided by our t1 minus t2. Now let us find the Jacobian. As in the previous case, if you recall, what was the Jacobian that we had? Dou xt by dou p, dou xt by dou q, dou yt by dou p, dou yt by dou q. So dou xt by dou q. So here when I have to differentiate this, I will have to go for x1 and x2. So when I go for my x1 and x2, the derivatives that I would get would be over here. The first one would be with respect to p will be 1. Then the next will be minus t1. Again with q it will be equal to 1. And then again it is going to be equal to t2. How did I get this? I had my x1 value is p plus qt1, my x2 value again p plus qt2. So when I differentiate this, dou x1 by dou p value is 1, dou x1 by dou q value is positive t1, dou x2 by dou p value is 1, and dou x2 by dou q value is t2. So now on solving this, the value that we get for the Jacobian will be t2 minus t1. Once we get the Jacobian value as t2 minus t1, we will proceed as in the previous case. The joint probability density expectation of my x of t here is the straight line. I have p plus qt. So e of p plus qt, this is nothing but e of p plus I will have e of q into t. Okay. So once again, the mean is also a straight line that has intercept of e of p. Therefore, the mean is also a straight line that has intercept of e of p. And what is the slope of the line? We know that if y equal to mx plus c, what is the slope? The slope is m. Here x is given by t. So the slope here is going to be e of q, and the slope is going to be e of p. I hope you would have understood till here. For it is a straight line, so it is a linear equation and quite simple to solve. The next characteristic what we are going to see is the autocorrelation function. So autocorrelation function for a straight line process. Autocorrelation function for a straight line process. Right. So autocorrelation is represented as Rxx of T1 comma T2. So this is nothing but I will have E of x of T1 into x of T2. So this is nothing but expectation of I will have, what will I have? Expectation of, it is P plus QT. So now it will become P plus QT1 into P plus QT2. Expand this. This is expectation of P squared plus PQT2 plus PQT1 plus Q squared T1 T2. So this is nothing but E of P squared plus I will have E of PQ into T2 plus I will have T1 plus I will have E of Q squared into T1 into T2. This is the autocorrelation function. Right? Suppose I know the second order density, then what will happen? So if the value of, suppose I know the value of the second order density, that is fx1 x2 of x1 comma x2 is known or is given, then I can go for Rxx of t1 comma t2 equal to integral minus infinity to infinity, integral minus infinity to infinity fx1 x2 of x1 comma x2 into dx1 into dx2. I can use this formula, substitute for fx1 x2 and then get the solution. Okay. The mean of the process obviously is E of x of t, that is E of p plus E of q of t into 0. So we have some interesting note. Okay. So we know that our E of x of t is E of p plus I have E of q into t. Suppose my E of q equal to 0. Then what would happen? E of q equal to 0, then I will have my E of x of t is just E of p, which is not a function of t. Therefore, it is not going to change as t changes. order density is inherently a function of time. However, the process x of t is not stationary of order 1 and is not going to be stationary of any order. Therefore, in general, it is not stationary, but if p of q equal to 0, then it is stationary. Shall we make this clear? So, in general, the process x of t, is not stationary. It is not stationary of order 1 and therefore not stationary of any higher order densities. Of any higher order densities. Higher order density. Okay. So higher order densities. Only when this particular case, that is this E of q equal to 0 is considered, then it is stationary. Otherwise, it is not stationary. Also, for the process to be stationary, second point, also for the process to be stationary, in autocorrelation, that is in Rxx of T1, T2 must be a function of, in this case, the time difference is nothing but T2 minus T1. That is, it should always be a time difference T2 minus T1. Except for E of q equal to 0, the process will not be stationary in autocorrelation. So, except for my E of q equal to 0, the process will not be stationary. The process will not be stationary in autocorrelation. Therefore, what can you say? Therefore, the straight line process, therefore, the straight line process, what we discussed now, is not a wide sense stationary process. It is not a wide sense stationary process. Therefore, I conclude that it is not a WSS process. So, we have completely studied the mean, the autocorrelation, the first order density, the second order density, that is, the characteristics have been completely studied for a straight line process, which is the first random process we have taken for study in this course. Thank you. So we have done an elaborate characterization